First thing is current flow. Current flowing is alternating. And the second thing is number of turns. Because as in DC machine, number of turns are very high. So already we know that L is directly proportional to the number of turns there. According to that, it should be more. And third thing is relative permeability. As relative permeability is very high for my DC armature because it's made up of magnetic material. So as it is developed with magnetic material, obviously inductance should be considered. Basically, this question seems to be damn easy and it's convincing question, but if you observe the problem here, let me take a DC machine. Yes, here this is our armature, and these are our poles, main poles. Now upon this armature I am going to keep some conductors. And let me take this rotor is rotating in this direction. Now if the rotor is rotating, and let me name this as conductor number 1, 2, conductor number 3, 4, 5, 6, 7, 8. Here we have to fundamentally differentiate the induced voltage in each conductor and the current flow. Now, if my conductor is at position 1, how much would be the induced voltage? Means here induced voltage, let me take my sinusoidal flux density waveform. If I take in my air gap flux density, and this is theta, and this is from here I am going to consider as theta. Now, what about the induced voltage? According to E is directly proportional to or equal to BLV. Velocity is constant, and anyway active length of the conductor is also constant. So whatever is remained is B only. So if this is the waveform, what about the induced voltage? Induced voltage waveform also will be like this. Now, this is the induced voltage E in conductor number 1 with respect to some time. Now, everybody feels that this is going to be the, what do we say, current waveform also, but which is not true. Here, let me take one more page. Here, if I observe the current waveform, now let me take one more machine. Already we know that DC machine got its closed winding. Let me consider our brushes also. I am going to take this as brush. Now, here, yes, that's the shoe. From here to here, induced voltage will be sinusoidally varying. But what about the current? As it is closed loop, let me consider this is one coil, another coil, another coil, another coil, another coil, another coil. If these are all conductors of the coils, if I am going to take armature current IA, this particular path should give some current IA by 2, and this particular path should give some IA by 2. Independent of the position of the rotor. That position of the rotor may be here, maybe after 30 degrees also the same thing will be there, after 45 degrees also the same thing will be there. Now, means if you observe in this case, independent of the position of the rotor, these particular conductors which are there under the south pole region, will have current in this direction, and under north pole will have in this direction. Now let me sit on one conductor. Let me take this conductor, and if I assume current as, let us suppose 30 amperes, here this is going to be 15 amperes and this is going to be 15 amperes. Okay. Now, if I take this,